So, okay, let's start with kinematics revision for the formulas and whatever the equation that we already did. So this is the revision session. So we are discussing about kinematics. So first of all, basically in the kinematics, so we will discuss about the formula of kinetics. First one is V is equal to U plus AT. So let's first understand what is V. V is the velocity. V is the final velocity. Final velocity. U is the initial velocity. This is U, initial velocity. A is acceleration. And T stands for time. T stands for time. So first of all, whatever the equation that we have written, V is equal to U plus AT. This is the first law of motion. Okay, so in this one, if okay, any doubt in this equation, V is equal to U plus AT? Wait. So this is the equation when a body is moving in a linear direction. So like this is a body. We applied some force on this one. So when the force is applied, initially U is equal to 0. When the force is applied on it, it will move with an acceleration of A, and when it reaches the final point, V is equal, the velocity will be the V here. Okay, so it can be the possibility when at certain point here U is equal to some value U. So and at a time, so like at a time duration T, it will be reaching at a point at a distance of D with an acceleration of A. So same way, if let's take an example here, in a vertical direction, if a body is freely fall from the top. So this is the if a body is freely from the top, so at the top the initial velocity will be 0 without any applied on the force. So like an apple will be falling down by itself from the tree. So initially the U is equal to 0. When it will be hitting the ground, so the velocity will be the V, and the acceleration, it will be in the downward direction. So the acceleration will be like it's a G. Gravitational force is applied on it. So the equation for this one is equal to V is equal to U plus here GT, and it will take a time T to reaching at from this particular height to here. So we will write it V is equal to this is equal to 0, and this is equal to, so V is equal to GT. Okay, so now we will move to the second law of equation. So that will be tell the relationship between the distance and the acceleration. So the formula will be like here, Vs is equal to ut plus 1 upon 280 squares. In the previous sessions or in the previous videos, we already discussed about the derivation, how we will derive the formula and all. So this is the second equation. The third equation of motion, that is equal to v square minus u square is equal to 2as. Okay, so there will be some more formulas associated. These are the three law of motions. Along with that, if we want to find the some more formulas we will have. So another formula will be have distance is equal to u plus v divided by t. So this is the relation if we don't have any acceleration, if we have distance, if we want to find out. So in that case we can use this one. So another formula that we have, Sn is equal to u plus a upon 2, 2n minus 1. So all these formulas, these are the revision of the previous sessions that we are discussing here. So now we are going to start basically motion under the gravity. So how the motion will be, this is -1 at the end, this is -1. Let me just correct this one, 2n minus 1. Okay. Okay, so motion in one dimension. Now we are going to start discussion about the motion in one dimension. How the motion, if the motion will take place, motion in one dimension. So motion in one dimension means basically the rate of okay, what exactly in the one dimension is. So this is the let's take an example of two dimension, then we will discuss about one dimension. Okay, so this is x-axis, this is y-axis. This is example of two dimension. In the one dimension means a body is on this particular point and it is moving only in this direction. Okay, it's not moving along with the y direction, it is moving in the one direction. Okay, so basically with the help of the one coordinate we can find the initial velocity and its final velocity. So let's have the discussion about first of all, let's discuss about a body is freely falling body. So freely falling body means in the first law of motion we already discussed about v is equal to u plus at, and where if a body is falling from top to the downwards, so this is the earth here we have, and this particle is freely falling. So initially the velocity is equal to 0, v is equal to u, acceleration is equal to plus g. So we already discussed v is equal to gt. So this is the first law of motion. Here same way in the second law of motion, if you will see here, v is equal to s is equal to ut, this is equal to ut plus 1 upon 2 at square. So this u is equal to 0, so this is equal to 1 upon 2 gt square. So this is the second gt square, so this will be the second equation. So same way the third equation will be so the third equation that we are going to discuss, the third equation will be v square minus u square is equal to 2as. So here we know that u is equal to 0, so v square is equal to 2, a is equal to gs. So we can write like this one, v is equal to under the root 2 gs if you want to compute the value of g only. Okay, so let me correct this one. Okay, so I think all is good here. So here in terms of this one, this we can some equations will be written like this one, v is equal to under the root 2 gh, because here s is the distance and h is the height. So if a body is freely falling, so normally we will take h. So both the formulas are correct, but if a body is falling from the top, so we will normally consider it as a h. Okay, so the last and the final formula for this one is, if we will take this one, Sn is equal to u is equal to 0, so this is g by 2 and 2n minus 1. So this is the final formula that we already discussed. Okay, so now the same in the last chapters we also revision about a projectile, a body is vertically so let's have a discussion about yes, tell me, any doubt? The fourth one is equal to Sn is equal to so basically if you will see here, a is equal to u is equal to 0, and when we substitute the value, this is the okay. So all these things we already discussed about this one. So now the point we are discussing, projectile projected velocity upward, vertically upward, vertically upward. So what we are going to discuss, this is the ground, and from here if I am throwing any body upwards, okay, so what would be my acceleration, what would be my velocity, what would be my initial velocity, final velocity. So we'll take here u initially. When a body is thrown, the speed is u. When it reaches at the particular height at the top of the point, so the v is equal to 0. And here acceleration is, we are sending to a body opposite to the gravitation, so acceleration is equal to minus g. So if you will understand these things, so now what we have to do, our first law of motion is equal to v is equal to u plus at. Substitute the value here. V is equal to, this is equal to 0, u is equal to u only, acceleration is equal to minus g and t. So we will bring this one, this is equal to minus u, this is equal to minus g, it will cut, so u is equal to gt. So this is the equation 1. Second equation that we are talking about, s is equal to, distance is equal to, so we will write it, h is equal to ut plus 1 upon 2 at square. Normally this is our equation. So now what we are going to do, we'll substitute the value ut plus so acceleration is equal to minus g by 2 and t square. Okay, so when you substitute this value, so this height is equal to, h is equal to ut minus 1 upon 2 gt square. So this is the second law of motion when we throw a body upward direction. Same way you can also substitute v square minus u square is equal to 2 you can write 2g minus 2gh. So how we substitute this value, v square minus u square is equal to 2as. So we'll substitute the value here, v is equal to 0, u is equal to u square, and the value of a is equal to this is equal to minus 2g and h. So here minus u square is equal to minus 2gh, this minus minus will be cut, so u square is equal to 2gh, so u is equal to under the root 2gh. So this is the next formula over here. So let's have a recap over here. So the when we are sending a body upward direction, so we will applying the this law of motions. So when we are sending a body upward direction, so this is the first equation, this is the second equation, and this one is the finally this is the third equation. Okay, so whatever we are discussing, this is the revision that we did last time. Okay, so we already discussed all the points. Now we are going to start our next unit. That next unit will be like in the 2-dimensional. When we are sending a body in the 2-dimensional, how we will do that. So in the next session, we'll start the motion in 2 dimension. If you have any question, you can ask me.